Now we are telling linear differential equation of higher order. First we are taking the equation d power ny by dx power n plus k1 into d power ny by dx power n minus 1 plus k2 into d power n minus 2y by dx power n minus 2 plus kny equal x. This type of equation is said to be linear differential equation of higher order. Here we have the nth derivative term. So the sum of the derivative terms equation is the sum of the derivative terms. Okay. So where k1, k2 up to kn, these are the constant terms, and capital X, RHS side we have capital X, now that is the function of x. This equation is also called as non-homogeneous linear differential equation of higher order, of nth order. Okay, so if x RHS side the function x is equal to 0, then that equation d power n y by dx power n plus k1 into d power n minus y by dx power n minus 1 plus k2 into e power n minus 2y by dx power n minus 2 up to kn with y equal 0. RHS said we have that function is equal to 0, then this type of equation is said to be homogeneous linear differential equation, is called as homogeneous linear differential equation. Okay, now we are taking the operator form of the differential equation. This non-homogeneous linear differential equation is taken equation number 1. This equation operator form is like this. So the derivative terms d power n by dx power n is taken as d, capital D power n. Second one, d power n minus 1 by dx power n minus 1 is capital D power n minus 1 up to first derivative d by dx equal capital D. So all are taking like this in the equation number 1. Then we get the operator form capital D power n plus k1 into capital D plus k2 into capital D power n minus 2 plus kn with y equal 0 is operator form of the equation 1. Okay, now we are taking the auxiliary equation. Auxiliary equation, in the place of d we are taking m. So that is put d is equal to m in f of d equal 0. That is f of m equal 0. F of m means in the place of d we are taking m power n plus k1 into m power n minus 1 plus k2 into m power n minus 2 plus up to kn is equal 0 is called as auxiliary equation. In the auxiliary equation we have n roots. By solving this equation we get n roots. By types of the roots we are taking the general solution of operator form. So the types general solution cases are one by one we are taking. First one, general solution form. First one, so if roots are of the type, then we are taking the general solution. First one, if the roots, all the roots are real and distinct roots, all the roots real and distinct, then the general solution is taken as y equal c1 e power m1x plus c2 e power m2x plus terms up to nth root cn into e power mnx. Okay, this is one type of the general solution form. Next, if the roots are real numbers and some of the roots are equal, then the general solution form has y equal, taking like this. For example, m1 is equal to m2 is equal to m3 is then remaining are different roots. So then c1 plus c2 plus c2x plus c3x square into e power m1x plus c4 into e power m4x plus c5 into e power m5x plus up to cn into e power mnx. Like we are taking the general solution of the form. If the roots are real and equal roots, some roots are equal, remaining are the different roots, then we are taking general solution form like this. Next, third condition, if some roots are one pair or two pairs of the roots are complex conjugates roots, one or two pairs of roots complex conjugate roots and remaining are difference, then general solution form taken as like this: y equal e power alpha x, one pair conjugate complex conjugate roots ఉన్నప్పుడు e power alpha x c1 cos beta x plus c2 sin beta x plus c3 e power m3x plus c4 e power m4x plus up to continuation cn into e power m1x. If two pairs of conjugate roots are there, two pairs of complex numbers are there, then we are taking the general solution as like this: y is equal to e power alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x plus remaining roots. Continuation c5 into e power m5x up to nth cn into e power mn x. Like we are taking the general solution. Okay, now we are tell about one of the problem. First problem, solve d cube minus 7d square plus 16d minus 12 with y equal 0. First we are taking this is the operator form. The operator form is f of d with y equal 0. Now we are taking this form, d cube minus 7d square plus 16d minus 12 with y equal 0. Auxiliary equation. The auxiliary equation of given operator form is f of m is equal 0. That is f of m equal m cube minus 7m square plus 16m minus 12 equal 0. This is the auxiliary equation. By solving this equation we get the roots. Now we can observe that whenever this function is equal to 0, for example we are taking m is equal to 1. At m is equal to 1, the function f of 1 equal 1 cube minus 7 into 1 square plus 16 into 1 minus 12. Substituted in the place of m we are taking 1. F of 1 is equal 1 cube 1 minus 7 plus 16 minus 12. 1 plus 16 17 minus 19, that is minus 2. So this is not equal 0. So next, when m is equal to 2, f of 2 equal, substituted m is equal to 2 in the equation, f of m is equal 0. So 2 cube minus 7 into 2 square plus 16 into 2 minus 12. Then f of 2 equal to cubic 8 minus 7 into 4 plus 16 into 2 32 minus 12. F of 2 equal 8 minus 28 plus 32 minus 12 is 20. 28 minus 28, that equal 0. Therefore m is equal to 2 is one of the root of auxiliary equation. So now we are taking the synthetic division method. The root is m is equal to 2. Now we are taking the coefficient terms of auxiliary equation. M cube coefficient is 1, m square coefficient is minus 7, m coefficient is plus 16 and constant term is minus 12. Now first place we are taking 0, adding these two terms, 1 plus 0 1, 1 into this one is multiplied to 2. 1 into 2, 2. Minus 7 plus 2, minus 5. Minus 5 into 2, minus 10. 16 plus 16 minus 10, 6. 6 into 2, 12. Minus 12 plus 12, 0. Lastly, we get that value is equal 0. So now one order of the equation 1 can be terminated. So starting this 1 multiplied with m square minus 5 multiplied with m plus 6 is equal 0. So we get the equation m square minus 5m plus 6 is equal 0. Solving this equation. So next 1 into 6 equal 6. Middle is minus 5m. So the factors of 6. So we are taking the multiples of 6. Minus 2 into minus 3 is equal to plus 6. Minus 2m minus 3m is equal to minus 5m. For that we are taking these two. Next, m square minus 2m minus 3m plus 6 is equal to 0. Factorization. M take common, m minus 2 minus 3 take common, m minus 2 equal 0. m minus 2, m minus 2 is the same. Take common. Next remaining is m minus 3. Now m minus 2 is equal to 0. m minus 3 is equal to 0. We get m is equal to 2 and m is equal to 3. So now we can observe that the first root is 2. m is equal to 2. m is equal to 2. m is equal to 3. These two roots are equal roots and real numbers. This is different and real number. So the roots are m1 is equal, m2 is equal 2 and equal roots. Two roots are equal and m3 is equal 3. So all are real numbers. By this condition we are taking the general solution. Is y equal c1 plus c2x. These two roots are equal na? So for that we are taking c1 plus c2x into e power m1x, and one more m3 is the different root that equal 3. So for that we are taking c3 into e power m3x. Substituted that c1 plus c2x into e power, in the place of m1 we are taking 2x. c3 into e power 3x is the required solution.